So runs test for large samples. Okay, so for large sample we said that n1 and n2 must be greater than 10. All right, so the runs distribution table cannot be used. So for large sample we approximate that distribution, the runs distribution table, to normal. Okay, so we need to know it's normally distributed. All right, where the mean is given as that. So the mean is 1 plus, okay, so make sure this formula is in your head when you have large samples. So the mean is 1 plus 2n1 n2 over n1 plus n2, and then the variance is given as this. All right, so take note of the formula, and then we'll find our test statistic. So this R is the number of runs. So first of all, I have to know the number of runs. Okay, just calculate the number of runs, and then know the mean. So number of runs minus mean over standard deviation, that will be your test statistics, and then you use that. You compare that with the z value, so z alpha on 2. Okay, remember we said that this is a two-tailed test, so use z alpha on 2, and then if reject h naught if the absolute value of your test statistic is greater or equal to z alpha on 2. Okay, all right, so that is when you do the rejection, and then you will be fine. All right, so this is an example on that. So this, when you count, the test statistic is there, and then remember n1 is 20 and then n2 is 30, so that it's more than, so it's a large sample. The number of runs there, if you count, is 33, so you have to find the mean. So 1 plus 2 times n1 n2, so n1 is 20 and 2 is 30, and then we have 20 plus 30, which is 25. This is the mean, and then the variance, which is the standard deviation, is this formula. So we just put in n1 and n2 and we get 3.6. So our test statistic, which is saying that R minus that, so our R, number of runs, were 33 minus 25 over 3.36, which gave us 2.38. And now we compare that with the critical value z alpha on 2. And z alpha on 2, remember alpha was given in the question as 0.05, so on 2 means 0.025, which is that, and then the value is 1.96. so you compare, this is greater than that. Okay, 2.938 is greater than that. So since conclusion, we reject h naught since z test statistic is greater than z alpha on 2, and conclude that the order of males and females in the skew for the registration was not random. All right, so that is that. So what happens that if the data is numerical, okay, if the data is numerical, what do you do? Now it's the same thing, the same approach that you would do. You will use the sample sizes. If it is large, if it is small, you go about that. Okay, but just that you have to first convert that data into qualitative. Remember, the runs test is done on qualitative data. So if the data point is numerical, the first thing you have to do is convert that to categorical. Okay, so there are techniques you would use to convert that. Some people prefer using the median to categorize that, if you are, whether you are above the median or below the median. Okay, so if you are above the median, we use a plus to label you. You are below the median, you use a plus, a minus to label you, or you can use a to indicate those who are above the median and B to indicate those who are below the median. Okay, all right, so that is that. So this is a typical example, so you have to find the median of that first. Okay, so if the median is 16, so these are the arrangements. You don't change the arrangement, just find the median. So this was just arranged to find the median, but when you get a median, come back to this. Is this guy above or below the median? So below the median, I can use a minus. This is above, I can use a plus. All right, this is below, so this is above, this is below, this is above, this is below, this is below, this is above, this is above, this also above, and this is above or equal to. So for equal, when it is equal, you cancel it out, okay. So above, this is also above, this is above, right? Equal, you cancel it out. Below, so when you finish, you count those below and those above, okay, and get your n1 and n2 and decide whether it's a large sample or a small sample, right? So you know that you have 1 2 3 4 5 6 7, okay, and then you have 1 2 3 4 5 6 7 8 9 10, I think. So n2 is a 10 and then n1 is a 7, okay. So it's a small sample, so you have to use a Rance table, okay. So the whole thing is numerical. Change it to qualitative and then you will be fine. All right, it's numerical. Right, so that's the whole idea, okay. That's the whole idea. So you did that and then you have your plus and stuff, okay. I didn't count it all. N2 is 9 and then our N1 is 7, okay. So small sample, write your hypothesis and then look for the Rance table, the K1 and K2, and take your decisions, okay. All right, so these are a lot of questions which you can go through. This actually is not difficult, so make sure you get a Rance table and then you can go through that. All right, so that is that for the Rance test. So we'll look at the other tests in later